This conference will now be recorded.
So when dealing with the full table scans, the first thing you need to do is check whether why Oracle came up with the full table scan in the first place. The first point of investigation should be looking at why full table scan in the first place. Why full table scan? Are the indexes good? Do you have a corresponding index? If the status of the index is good or not, status is valid or not, then check if you have good statistics or not. There or not good statistics. There are cases. Wherein statistics feedback, or previously you can call it as a cardinality feedback, even the dynamic sampling can cause issues at times, guys. So in the presence of bad statistics, these things are more bound to happen. So your first line of investigation should always be, why did I perform the full table scan? Is it necessary? Do I have the predicates? So the easiest way to even after looking at this, check the history. Check the history regarding the plans. Whether do you have any alternate plans in your AWR? So how do you check this? It's very simple, guys. You have a script, SQL ID underscore info that I have given here. So let me just increase the font size. So it's pretty simple. All you have to do is at SQL ID underscore info, the script will show you the plans not only in your cursor cache, the current plans, but also in the history, how many plans are there. So I have 2 plans here in the history. So you can compare the plans as well. Here itself, by looking at these statistics itself, you'll get to know how much time it took previously and now how much time it is taking. How many buffer gets did I actually, how many buffers did I actually touch? How many disk reads I did to all these statistics you get, guys. So here itself, this will give you a very good starting point to find out what has happened. Then you can investigate in the line why the plan has changed. The second and the foremost thing is the plan has flipped from nested loops to hash join. So in these cases also, so hash join specifically, you need to remember, if I am joining two tables, table A and table B, table A has the smaller result set considering the predicates. So when performing a join, if you don't have any predicates on table B, eventually if optimizer picks up a hash join, it will proceed ahead with the full table scan here. Initially, first table, it will always scan it with the, so I'll show you a small example and then we'll proceed ahead. So this becomes a basis for your joins as well. So let me just show you a different fundamental. So I'm just loading the data into my students table. I think this is done. So let's check size. I have the students table here. I'm going to create a different table. Create table B as select star from students. Alter table A. Rename to, sorry, alter table students. So I'm going to add a few indexes, guys. So once the statistics are gathered, I'll show you a small thing. I mean, there is a big misconception out there, especially when it comes to the hash joins. So don't assume that by default, the larger table you would end up accessing using full table scan, especially while performing a hash join. This is not necessarily true. This is not necessarily true. So let me just run a small query so that you get to see the things more clearly. Here I have two tables here, table A and table B. I'm going to show you the indexes that I have in here. Table B, Vishnu. I have an index on Mark 4 column on table A and also the student ID. Similarly, I have index on Mark 4 and the student ID column as well. So let me run a small query case. Select A dot department ID, comma, sum of B dot Mark 1 from table A, table B, where A dot student ID is equal to B dot student ID and so, so give me a minute here. This thing would eventually go with a nested loops here. Okay, whatever the case, I'm gonna force a hash join here. Once this is done, so can you notice here, guys? Everyone, can you notice a significant thing here? It's not, no, don't assume that hash join is very costly. Hash join is very costly. In certain cases, optimizer can come up with index range scan while scanning both the tables. So it is especially the, there are many books and blogs that says that the hash join you would end up performing a full table scan on the larger table. Here the table B, you should, yeah, you can consider it as a larger table, but honestly speaking, why did Oracle go with the index range scan? So it is because I have a filtering condition on table B also. So if I don't include a filtering condition on both the tables, suppose here table B, I'm not including a filtering condition. In this case, okay, let me just force a nested loops plan here. Use hash of A comma B. So can you notice here, guys, everyone? It is only when I do not include a predicate on the larger table, then only, and moreover, if the column is not indexed, or if Oracle finds that accessing the table B using that particular index is very costly, then only Oracle will proceed ahead with the full table scan. Guys, it's not always. So don't automatically assume that the hash joins are very costly. In fact, there are several scenarios wherein the hash join is way cheaper than the nested loops. Way cheaper than the nested loops. You have to understand one thing. Nested loops, you end up probing this table B over and over again for each row you get from table A. So once this thing actually crosses a certain threshold, things get really ugly. Things get really ugly. So you end up accessing more rows. So don't automatically assume that hash joins are way more costly than the nested loops. There are many scenarios wherein the hash join is way cheaper than nested loops. So now proceeding ahead, check whether if the plan has flipped from nested loops to hash join, and moreover, you are looking at a full table scan on the larger table, table, or it's not okay. A larger table for now. Just think it of as that way. So now there are certain scenarios wherein full table scan cannot be avoided. A full table scan cannot be avoided. In these cases, the first and the foremost thing you should see is whether the asynchronous IO is enabled or not. Check whether the asynchronous IO is enabled or not. Asynchronous IO will help you read data faster. Instead of using synchronous calls, you end up using asynchronous calls. And moreover, even before finishing up with the first read operation, even before finishing. So, one moment, guys. This thing, okay. Even before finishing the first, even before waiting for first IO operation to complete. I mean, first IO operation in the sense, if you have issued IO submit call, instead of waiting for that IO to complete, in the meanwhile, your server process or the Oracle session will initiate another IO request. This will help you considerably. And moreover, check whether if there is fragmentation. Check if there is any fragmentation at the table level. So what is the fastest way to check the fragmentation, guys, instead of running segment advisor? Everyone? So people usually make a mistake of running the segment advisor instead of running the segment advisor. So for a table, is there any alternate way to check
Row,
the bloat?
row average length.
Row
Yeah,
average length
yeah, there's a
and
stat.
number of rows may
Yeah.
not be.
So, no, blocks multiplied by number, I mean, block size multiplied by number of blocks. And then average row length multiplied by number of rows. So the difference.
Average row length is an aggregate value. This will not truly indicate the bloat. You won't get the accurate measure of the bloat. So let me just give you a small thing, and the fastest way to get the actual bloat information. So you can make use of dbms underscore space usage procedure, guys. Dbms underscore space usage thing. This will give you the best, fastest way. I mean, this is the fastest way to get the bloat.
We are not
So
seeing
let
this.
me just, no. I'm just trying to search that particular script. Do I have that? One moment. So one moment, guys. dbms underscore space usage dot. Even I have to search it here. So one moment. I do have the things stored somewhere. So let me just see here.
Yeah, we have a script that will check the high water mark. I think that makes use of the same file that you're talking about.
No. One moment. I think. No, this is not the actual script. Mhm. This is also not it. Okay, this is also not it. So give me a minute here. So in the meanwhile, yeah, I think we have the actual script here. So I'm just trying to Google, guys. Normally, as you guys on the Oracle base, I do have it here. So this is the fastest way, guys. Let me just run it here and then show you the data. Owner name and type. One moment. I think I have to modify the script. I don't want to run this one. This is just for the demo purpose. So there is no partitions here. I think I should have this scripts handy. Hmm. So I think there is a small issue here, guys. I'll try to get this script ready and then I'll show it. So I think I do have another thing here. Let me just see if this thing actually helps us.
Vishnu, I guess you renamed the students table to table A.
Yep.
Yeah, that might be the reason that table does not exist.
Yeah. Now, can you see the bloat, guys? Everyone? This is the exact way to identify things, guys. So I have almost, how many blocks are there? Most of the blocks are basically full. There are only a few blocks left in the segment with less usage. There are only a few blocks left with the less usage. This is the fastest way, or this is even the better way, better approach to identifying the bloat in a segment case, in a table. So fragmentation in a particular table, because this thing will not do a full table scan or anything like that. It just looks at the L1 BMB blocks at the segment level and then gets the data from there. So I'll talk about L1 BMB blocks. What are L1 BMB blocks? What are L2 BMB blocks and what are L3 BMB blocks when I'm discussing about ASSM. For now, just remember that L3 BMB block becomes the segment header. So we know that the bitmap blocks are used to track the freeness status of data blocks. If you are using ASSM, yes, you have to understand that these blocks are basically stored in the form of an index structure also. So L1 BMB blocks are the actual blocks which contains the details regarding the freeness status. So the L1 BMB blocks are always allocated at the initial position of your extent. Suppose say this is my extent of size 1 MB. The very first extent will be an L1 BMB block. The second extent will also be an L1 BMB block. So depending upon whether the extent is allocated initially or at a later point in time, then you will have subsequent L2 or L3 BMB blocks. If the extent is allocated initially, then this one becomes the L2 BMB and then this thing becomes the L3 BMB. Only after this L1 bitmap blocks only you can basically store the user data. So any block, any extent that is allocated to the segment, the initial blocks in the extent are always bitmap blocks. These bitmap blocks, actually what they do, they track the freeness status of the data blocks. So let me just show you that and then we'll proceed ahead. So this is the initial block. So I'm going to dump this particular block, guys. Dump block 7. So can you notice, guys, everyone? So even way before, what I'll do is I'll dump even a better one. So can you notice, guys? Here, all the blocks are basically full in the sense I have filled up the contents of the data block, table block. So I cannot add even more data here. Once I reach the PCT free threshold, Oracle marks that particular block as full. I cannot insert any data into this particular table block unless I delete some data in the particular table blocks. Can you see the status, guys? This is the dump of the first level BMB block. So these L1 BMB blocks are the table blocks, are the blocks which contains the actual freeness status. So when you are inserting a data into the table, you can't just go and blindly insert in a particular block. Instead, you need to find which block has the free space. How does Oracle even find out this information? It starts by reading the L3 BMB block, which is the segment header block, which contains the details regarding all the L2 BMB blocks as well. So it reads the L3 BMB block, then an L2 BMB block, then finally an L1 BMP block, and then find the table block which contains the enough free space. So even for inserting the data into the table, you need 3 lookups, or you basically traverse the bitmap structure, bitmap blocks. These blocks are basically, think of these as arranged in the form of an index structure, guys. So you start at the root, branch, and then leaf. Similarly here, you read the L3 BNB block to get the details of the L2 BNB block, which contains the enough free space, and then finally, after reading the L2 BNB block, you find out the L1 BNB block, which has the details regarding the free space, and then after reading the L3 BNB block, you will find out the actual table block which contains the free space. Then you insert the data into the particular table block. So subsequent insert, you don't walk along this entire thing. Directly you'll go ahead and then insert in this particular table block. So I'll talk about in-depth regarding ASSM in the later sessions. For now, just remember that the freeness status of the blocks is managed using bitmap blocks, and then L1 bitmap, L1 BMB blocks are first level bitmap blocks, are the one which contains the actual details regarding the freeness status. So the fastest way to check the fragmentation in a particular table is to make use of dbms underscore space dot space usage. Yes, average length, number of blocks allocated, the block size, yes, you can use it. But so here blocks, are you considering the blocks below the high water mark or all the blocks allocated to a segment? What if I had added an extent manually? In this case, both the things actually fail. In this case, both the things actually fail. So you need to remember that scenario. And finally, if the full table scans cannot be avoided, see if you can partition the data. So the orders table, what I would do is I will talk to our developers to see whether if they can push a predicate on the date column. So if they are interested only in certain orders for the past 1 month or something like that, I can even consider partitioning the table. So remember guys, partitioning is an additional paid feature. So, and another thing, from the database end, check whether if your data files are spread uniformly or not across all the available disks. This is also one of the reasons, your full table scan actually performs slow. Suppose say I have three file systems, and I have the data files on all these three, yes, uniformly distributed. The data files are uniformly distributed for the table space which holds this particular table. But what if the user load is concentrated on this particular file system only? In this case, the utilization of the disks holding this file system actually increases considerably. So what if one of the disks are running at 100% utilization and the rest are basically 20% or 30% like that? So in this case, when you're reading the blocks from these two file systems or data files present in these disks or file systems, whatever it is, so you will get good response times. But when it comes to this particular disk or file system, things get really slow. So check whether if the load is balanced across all the available disks or file systems. If you have multiple file systems to hold your data files, check whether if the load is uniformly distributed. This is one thing. Finally, chain rows. So gathering the statistics will not, if you use the dbms underscore stats.gather table stats, you will not populate the chain underscore CNT. You will not populate the chain underscore CNT. It is populated only when you run the analyze table compute statistics procedure. So what is an alternate way to identify whether if a session is encountering the chain rows? In this case, you have session level statistic called table fetch continued row. So let me just show you that. Can you see here, guys? So if a session is performing a full table scan and constantly if you see this statistic value incrementing, then it typically means that you are encountering the chain rows, and moreover you would end up seeing DB file sequential reads. So why do we have to check the statistic? What if the table is basically what if the SQL statement is part of a join? Is a join. In this case, isolating particular object read based on the wait event just by looking at the $$ session view can be difficult, guys. So it's always good to go with this particular metric, table fetch continued row. So if you have a nested loops and a hash join, all these things are involved in your explain time. If you have multiple tables involved, and moreover, if Oracle is choosing a nested loops and a hash join, something like that, in that case, isolating whether one particular part, isolating whether if you are encountering the chain rows on a particular object based on the reads is difficult. So try using this particular thing as table fetch continued row. Then also you can also use $$ active session history to track the details, but honestly speaking, remember this may not contain all the data. So how many of you actually rely on $$ active session history, guys?
We do.
So everyone, how many of you think that it is accurate?
Yes, we think.
So even the AWR. So I'll run a small workload wherein you get to see the fundamentals. So be ready for another surprise. So I'm going to start loading the table data into my students table. This is more than enough. So here I'm going to run a sample load here, guys. Sample load, and then we'll proceed ahead. So string of temp is equal to SQL. Suppose say 200000. So 2 million. Yes. So now what I'm going to do is I'm going to So let me show you what happens here. So I'm going to have 10 sessions. Basically run this load, guys. Let's see. So moreover, I would end up with a full table scan here. So alter table students and the constraint student underscore key primary key of student ID. So let me just show you the fundamentals here. I'm just creating an index here. Now I'm going to run the load. Let it run. Let's see the weight events. So can you notice any weights here, guys? Everyone? Any weights? Guys?
No waiting.
Idle weights.
So there are no weight events here. So let me just do one thing. Let me increase the number of sessions and run the same thing over again. So you should end up seeing weight events now. So yeah, and this is not, I don't know why today it's not coming up as expected. So I'll do one thing. I'll make it even worse. So let me see. I mean, I might be looking at something here. So it should come now. So let's see. You should end up seeing insane weights now, guys. So what I'm going to do is I'm going to stop the load for now. Just 10 seconds. I mean, using 10 sessions only is more than enough to simulate the loads. And moreover, in order to demonstrate this, I'm going to start up my instance again. I don't want the data to be skewed here. So let me restart my database, post which we'll look at the weight event. We'll run this workload for exactly, suppose, say 15 or 20, 30 seconds or even a minute. Then look at the aggregate weights. So I'm running the workload right now. Notice the weights, guys. I'm looking at the latch shared pool, row cache mutex, library cache also. I am looking at library cache related weights. Latch shared pool also I'm looking at. Guys, please place your call on mute. So I'm going to execute this. Okay, this is more than enough. I'm going to stop this load for now. From the ASH, let's see the weight events. Select event count, sum of wait time plus time waited. I have restarted the database before. So A order by 2. So let's look at the weight events, guys. So can you see, can you observe the weights, guys, everyone? Hello?
Yes.
Now, there is one another interesting thing you need to remember here. Where did the row cache mutex weight event go? I had sessions waiting on row cache mutex. Yeah, I do have this thing coming up here. Latch shared pool. I have library cache wait. I should have some other wait event that should not be recorded. Give me a minute here. One more. Library cache. Okay, that's all right for now. So I'm gonna do one thing. I'm gonna create a dbms underscore workload.repository.create snapshot. So select event comma. I'm gonna use the same query here. I'm gonna check in the AWR. So can you see the weight events, guys? In the snapshot, in the AWR?
Yes.
Yeah.
So what happened? Can you see the significant difference here? So
Yes.
my weight event row cache mutex in the ASH, it says that I waited too long, but in the AWR, it is even not listed. So can you notice the log files coming up?
Yes.
So now tell me, can you rely on AWR? Latch shared pool, which was my second topmost weighted event, became the least weighted event. So I took a snapshot here, select max of snap ID from DPA hist underscore snapshot. So I'm going to use the same query here, guys, where snap ID is equal to 18. So the snapshot which I just created and module like JDBC, I have only JDBC connections coming up from my application only. I just restarted the database, ran the load, and then gathered the snapshot. So can you see the things, guys? Everyone, can you notice? Can you rely on AWR, guys? You have to understand one thing. By default, ASH sampling time is 1 second. The default ASH sampling time is 1 second, and in AWR, the sampling time increases to 10 seconds. You will have the entries every 10 seconds. So 1 second is enough to truncate much data also. So in a true OLTP application, this 1 second sampling time will also does not make sense. Okay, will not also make sense. So let me just show you that. So you have this hidden parameter. At hidden ASH underscore sampling interval. This is the hidden parameter, guys. It defaults to 1000 milliseconds, in this case 1 second. So don't trust. You cannot, honestly speaking, looking at the way, just now you saw a small example, guys. Just now itself you saw a good example, and there are even more scenarios. So I'll put it in a different sense. So here I'm not doing anything drastically different here. I'm just trying to show you the true picture. So here I have the student ID. So what I'm going to do is I'm going to use this. I'm going to execute this statement alone. So let me show you again. I don't want this particular thing out. I want to use bind variables only. I don't want to use any other binds, any other values. So suppose say 2 million. Okay, now I'm going to run the same load. So let me just start up the database again. So execd underscore workload underscore repository dot create snapshot startup force. We know that, let me just start up the instance again, and then I'll fire the workload, guys. I'm going to start the workload. I'm going to stop it after a few seconds probably. Then run the snapshot again. So I'm running this query now. Yeah, I think this is more than enough. I'm going to stop it for now. At ASH1, this is my SQL ID. How many times did it execute, guys? Everyone? Hello?
91K.
I know that it has executed 91,000 times. This is my SQL statement. And if I check in the AWR, do I have even a single row here? Hello?
No. No. No.
So I'll proceed ahead, guys. So
So Vishnu, one thing, this sampling time can be altered or it's fixed, like
yeah,
by
you can
default.
alter. You can alter, but the side effect is once you alter that, your AWR bloats insanely. Your AWR bloats insanely, resulting in the sysoc stable space to increase considerably. So till date, you believe that AWR contained the entire data, right? Everyone?
Yeah.
AWR records only top 20 SQL statements, right?
So here I don't have any other load, right? AWR records the top 20 SQL statements, yes, but there is no load on my database apart from my users who have connected post restarting, right? Can you get it? Hello?
Right. So basically, the per execution is completing very fast, right? That is why it is not captured in AWR.
Yeah, no, that's not just the case. There are many cases, yes. That's not just a single case. I mean, you cannot get a valid consensus based on this alone. So there are too many scenarios. There are too many scenarios. I just want to show you. I mean, my point is to show you that the data might not be present. Here, in this case, suppose say if you had a performance issue between 11 a.m. and 11:10 a.m. and if you are going in the AWR, what if this thing happens, guys? Tell me. You're just looking at the data, right? Here itself. In the ASH, you have the accurate data saying that most of my sessions ended up waiting on Procatch mutex. But when I digged in the AWR, the second topmost weighted event became the least one, and the other thing came into the picture, which is not even recorded. So, how accurate is your analysis using AWR? Right?
So
So
let's
let
say if a performance problem is running for 2 hours, then AWR is very, kind of useful. But if you want to dig something like 2 minutes, 5 minutes, then that will fail. Is that a right statement?
this part also is not accurate in many cases. So the approach, this default approach is completely flawed. You cannot isolate the true issue in all the cases. So I'll put it this way. Yes, whatever you said holds true in some cases. So I would put a statement, guys. Don't draw conclusions. So you just saw a scenario. Don't just draw conclusions saying that things will not work. Instead of drawing conclusion, you should always, when it comes to the performance tuning, you should always say that yes, this is one scenario wherein things did not work. There are other scenarios where things work. Just because we don't know the other scenarios, we just comes up drawing conclusions. You get the thing, right? I'm just saying always you have not always as the possibility. For everything you observe, always have not always possibility. So if you basically draw, I mean, suppose say you looked at some weight event and then you find out that things did not actually match what you looked at. In that case, you will end up drawing conclusion, or you think that. So I'll put it in a human sense. So once you draw a conclusion, you will never look at the other possibilities in which you can get the issue. You will never even assume the possibility. So I'll put it in a different sense. How many of you think that MQTX alloc ITL wait event actually comes into the picture only if multiple sessions are trying to add an ITL entry and there is no free space? Guys, in the table.
Yes.
Yeah, this is correct.
No. Even if the block is 100% full, the sessions, even though there are 100 sessions or 10 sessions actually trying to insert or modify the contents of this particular block, you will not notice this. It is when there is a significant delay between a session inserting and then committing the transaction. This is when you get to see this.
What is the wait event, Vishnu? Can you please repeat?
NQTX alloc ATL wait event. Yeah, not just this wait event, man.
Okay.
Everything you will notice. Everything you will notice, not just this wait event alone. I mean, this is one of the examples that I'm saying. There are too many things wherein things are not optimal as what you think it is. So don't assume that this is the only condition. So whenever you are troubleshooting any performance issue, don't just assume that this is the only case. Always think that this is one of the cases. If you if you think that way, you will always consider a possibility wherein things can appear in a different way as well. I mean, different scenario can also result in this particular thing. So I'll put it in a different sense. How many of you even think that the latch catch buffer chains comes due to the hard blocks? Everyone?
Yes, that's what we know.
Yes.
So what if I say the root cause of a select statement waiting on latch catch buffer chains is not related to any of the hot blocks, but instead an update running on a different table? How many of you think that this is the possibility? Sounds really weird, right?
Yes.
Because the true explanation no one knows. Most of the people think that it is hard blocks, and in the blocks you will find out that this is due to the hard blocks. So I'll put it in a different sense. Don't just read or think whatever you are looking at is actually the fundamental truth. So always consider that this is one of the cases. So that is only when you will get to learn this. And moreover, coming back, chain rows.
Vishnu, sorry, just one question, Vishnu. Is the SQL monitoring again picking the data from the ASH, or is that a slightly more accurate
SQL
data?
monitoring, yes, SQL monitoring is accurate. I'll put it in this way, accurate. Mostly accurate.
Okay.
I'll put it in this way. SQL monitoring is mostly accurate. But instead, I would not, when I troubleshoot the performance issues, I don't rely on DBMS underscore SQL monitor, but instead I rely on $SQL plan underscore monitor view to basically see what is going on in the real life. So how many rows are processed and everything, and I put it in a different sense. This is also not continuous. So there will be a gap. So yes, this is mostly accurate guess, not 100% accurate, mostly accurate. So
Okay. Thank you.
I'll put it in a different sense. Mostly accurate does not mean that I am saying that you will get inaccurate data. You get it, right? I'm not saying inaccurate data.
Yeah, got it. Yeah.
So I'll put it in a different sense. If someone says the share price is 1000 rupees, and then by the time you go and check, it's 1024. Yes, this was accurate a while ago, not now, right? The accurate data I reported, but I didn't report it at the right time. Yes. Anyhow, the data is basically accurate, but didn't report it at the right time. So that is another scenario. So I don't want to go there. So the chain rows can have an impact, and provided that you are selecting the data only from second row piece only. So if you have chain rows in a particular table, what is the best thing you would do, guys? What is the best thing? So now let's see whether you have a DBA mindset or an architect level mindset. So what is the first thing you do, guys, if you find chain rows in a table?
So two things we do normally, like first, I mean, sometimes we move it to based on how many chain rows are there, what percentage.
Mm-hmm.
And second, one very specific scenario in one of my client, what we
Mm-hmm.
do is I just fetch the chain rows in a temporary table and then put it
Mm-hmm.
back into the same table.
So we are troubleshooting the issue, but we are not addressing the issue here.
Yeah, Vishnu, we
Addressing
can
the
move
main
it to
issue.
a table space having higher block size.
Yes, yes, this is the thought process you should have. You should prevent this issue altogether, prevent the chain rows altogether. You should always consider this particular option. The first preference should always be to prevent this issue coming up. So as a performance tuning DBA, your thought process should always be to prevent a particular issue from coming up in the future, not just fix things momentarily. Yes, the business demands you to fix things momentarily, but you also have to take this step to prevent the issue from coming up altogether. Yes, both the answers are correct. Both the answers are correct. If you are just troubleshooting the issue for now, you would always get this issue again and again. So your second thing, immediately you should, if you are looking or eyeing towards this particular role, your thought process should be to prevent this issue coming up again. So hope you get it. Then finally, delayed commit cleanout. So it's not just the DB writer writing the blocks to the disk, it's also the other sessions if they are trying to pin the buffer in an incompatible mode, then also the session may not commit, clean the ITL records. So the delayed commit cleanout can also be one of the reasons, but the chances are very less case. The chances of delayed commit cleanout are very less, unless you don't use auto commit and there is a significant delay between you. So there is a significant delay. I'll add more things here. I mean, for now, just remember that this scenario is
Tim,
very less compared to the ongoing. Yeah.
for chain rows problem, right? We tinker with the PCT free percentage. We try to reduce that. Is it a good
So
approach?
PCT free. See, I'll put it in a different sense. I have 200 columns in my table. So if I fill the entire data or even almost subset of my data, I would end up increasing the blocks. I mean, I would end up having a row whose size is greater than the block size, right? Suppose say.
Right.
So I'll put it in a different sense. This is not your mistake. So this is the mistake done by the developers. Developers are clueless regarding what are the table average sizes, what are the block sizes, how many rows can fit in a block. All these things they don't care, guys. Developers don't care. They want this table, and Oracle should create the table, load the data into that particular table, and finally get the results from that particular table as fast as they could. So this is the only thing that developers care about. So it's the DBAs or the schema designers or the architects who actually come up with the schema should consider all these things based on the technology and then decide, take a prompt decision. So the 8K, when you create a database, you end up creating an 8K table space, 8K block size by default. This 8K may not be better for each and every table. There are various cases wherein, so I'll put it in a different sense. There are many cases wherein you have to store a particular object in a 16K block size table space, or in some cases you need to store the object in a 4K block size table space also. this thing also will come into the picture. So we'll talk about those things also. So for now, just remember, guys. So ongoing transactions. So yeah.
Vishnu, so we may encounter the issue, the same issue when there is a difference from the OS block and the database block also, right?
Yeah, nothing, man. That is nothing. So you don't have to worry about that. I get what you're trying to say. Misaligned writes, reads, and everything. That concept is there. Yes. Yeah. You're talking about this part. Okay. You're talking about this part, right? So the OS related page size is 512 bytes or 4 KB, and then my database block size is 8 KB, right?
Exactly. Yes.
So I'll put it in a different sense. ext4 file systems, can you make it 8 KB without recompiling the kernel?
No.
You cannot do it without recompiling the kernel. So 8 KB block size is not 8 KB block size or 8 KB page size at a file system level. You need, I mean, it's not easy.
Need to
It's
come
not
up with certain
easy.
parameters from the database to replicate the
I'll put
blocks.
it in a different sense. I'll put it in a different sense. 8 KB block size, 4 KB page size. So you are reading 8 KB in a single IO operation. In this case, you are reading adjacent blocks only, right?
Yes.
When the blocks are adjacently stored, very less minimal IO overhead or very minimal overhead, guys. Very minimal overhead. You won't even notice it. You won't even notice it. I'll put it that way. You won't even notice it.
Got you.
So yeah, there are misaligned writes, the Postgres, MySQL, SQL Server, they talk about this stuff. Your page size should align with the block size and all those things. So that two calls, instead of issuing two calls, I'll end up issuing one call. But as you can see, period 64 call, I'm reading only one, I'm making only one call, right? Hello?
Yes, yes,
Right.
yes.
Yes.
So that
So Vishnu, this is the
misaligned,
same thing which you say, like the huge pages come into picture, right? When we supply the large number, I mean, big size of page from OS.
huge pages is a memory, man. Is the memory related to the pages in the memory. That is different.
Oh,
Now I'm talking about the disk part. See, the memory, I'll put it in a different sense. So each RAM has a frequency, right? Every RAM has a frequency, right?
Yes.
800 megahertz or something like that. This frequency will dictate the aggregate bandwidth that you get from the memory. So I mean, it's way too faster to even consider that thing coming into the picture, guys. It does not come. In real life, it does not come. Just for theory purpose for learning, okay, it's good, but it does not come. And moreover, regarding the huge pages, I'll talk about the huge pages, the page table size. When does that increase? Will that actually cause CPU consumption, increase the CPU consumption and everything in the subsequent slides, subsequent sessions. So for now, just going back. So delayed commit cleanout and ongoing transactions. So out of these two, this is more likely to have an impact than delayed commit cleanout. The chances are very less unless there are explicit scenarios only. So you don't have to worry about this more, but rather this thing has more chance of happening. So in this case also, VDOL or SESTAT or SYSTAT, you have these statistics that I mentioned yesterday. So let me just bring that slide here. So commits only consistent gets, and commits and rollback consistent read gets. These are very handy when you're troubleshooting the issues case. So finally, this particular wait event NQKO fast object checkpoint. So the NQKO fast object checkpoint, we know that it happens, so I don't think I'll bring the slide here. Sorry guys, I had to sleep way late yesterday. I was working on something. So yeah, let me bring this slide here. So NQKO first object checkpoint. Yes, we know that it happens just before a full table scan, wherein Oracle writes all the dirty blocks related to the segment onto the disk. Yes. So it happens, NQKO first object checkpoint happens, especially when your select state, when your session went up with direct path read, went with the direct path read only. So this is to, I mean, buffer cache, I have already explained this. The buffer cache can contain the dirty blocks which contain the latest data, and the on-disk version may not contain the latest data. So Oracle to circumvent or to come around this scenario, wherein reading the data from the disk will result in bad rows, bad data. So you end up performing an object level checkmark. Yes, these are the basic fundamentals, guys. So how does the session, how does the process actually work? How does the process can actually work? How does the process actually works? Now let me just bring it here. So the session notifies or pokes the CKPT process. It notifies the CKPT process to perform an object level checkpoint. So in proper terms, in programming terms, you end up waking up the, or the proper, you call it the posting, guys. In programming terms, you call it posting. So a session here, simple terms, notifies the CKPT process to perform an object level checkpoint. The CKPT process, what it does is, it looks in the buffer cache, and then it, if you have dirty buffers, it prepares the entire list of dirty buffers and then sends it to the database writer. Here, your session end up being blocked by the CKPT process, not the database writer process. The blocking session, if you see it, you will end up seeing the CKPT process. It is the checkpoint process. You are being blocked by the checkpoint process because this checkpoint process is basically the one which is preparing the dirty blocks, and in fact it's doing the object level checkpoint. So now this checkpoint writer, what it does, prepares the list of dirty blocks and then hands it over to the database writer process. This database writer process, what it does is, it writes these dirty blocks to the disk. Yes, if there are any ongoing transactions or whatever it is, it can even post the log writer. So if there are any uncommitted changes related to this dirty block, and moreover that redo is still present in the log buffer, this database writer can also post the log writer to write the corresponding redo information onto your disk as well. So session posting the CKPT process, and then the CKPT process posting the database writer process, and the database writer process posting the log writer process. This is the worst case scenario. This is the worst case scenario. So worst case scenario in the sense, it does happen at times, especially if you have a table which is being modified insanely, modified a lot. So it is only after all the dirty blocks are returned to the disk, then only your session is allowed to even read the blocks belonging to a segment. So more number of dirty blocks, more time it takes. Rack environment, things get really messy. So Exadata environments don't place your load on multiple instances. In fact, Oracle itself recommends that don't run this particular thing. They don't run load DML statements on multiple instances. This can slow down your object level checkpoint, especially in the context of direct path read. So why are, and the second thing, so here the performance of the object level checkpoint is directly dependent on the availability of asynchronous IO. We know that. So the database writer can even batch 1,000 blocks also in a single write operation, provided if you have enough IOPS. So it can even write 1,000 blocks also. So now, yes, you have the asynchronous IO enabled, but even then you are looking at this wait event. So the second thought process should be, why are there more dirty blocks in my cache? Is the fast start MTTR target configured properly? So I'll put it in a different sense case. I'll ask you a simple question. So can a dirty page or a dirty block in the buffer cache? So I have a dirty block in my buffer cache. How long can it stay here, guys? Can it stay for an hour? Everyone?
Depend on the checkpoint and the pressure of on the buffer cache.
So no pressure, no activity on the database.
So until the checkpoint happens, it can stay.
Yes, until the time either the incremental checkpoint or full checkpoint happens or a log file switch is triggered. So until the time it can stay for as long as possible. So most of the environments, production environments out there, fast start MTTR target is not configured properly. So set it accordingly, guys. Set it accordingly. Based on your business requirements, set it accordingly. Setting this value to a 2 less value, setting this value to a very low value, suppose say 1, or if you set it to 0, then Oracle simply ignores in the sense there is no threshold enforcing how much time a dirty block can be present in a buffer cache, something like that. But default value is very dangerous in a production environment,
So basically
especially
the
in
default
OLTP.
value is 300, right? So
No. So I just created the database.
okay.
Show parameter fast start. So I'll show you in a different sense. I'm gonna reset the SP file, so that way you get to see the true behavior. So I have the init SP file dot. So you can see what this SP file actually does. The program you already have it. So do I have a fast start parameter, guys? Fast start MTTR target?
No.
No, right?
No.
I'm gonna run this command reset SP file. What it does, it brings down the database and then basically creates an SP file using this particular file. So let me just show you that as well. cd dot commands cat. Can you notice here? So let it come up. So the default value is always 0. So it means no limit. So a dirty block can stay for even a longer time. So this is one thing you need to remember. And moreover, ensure that log switches happen at regular intervals so that the dirty blocks are written to the disk as well. So there are several scenarios, guys. There are mismatches also. I'll talk about those things when I'm dealing with the buffer caches, but not now. For now, just remember that, your approach should be to minimize the number of dirty blocks in the disk. But don't go too far, because this can have side effect wherein you will increase the IOPS on the server considerably. Unnecessary writes, so you end up writing the data more often, so it's not necessary. So Then check whether if your disks are highly utilized also. If your disk, you have to understand that writes performed by the database writer are mostly random writes which consume IOPS at the storage layer. So, which consume IOPS. Suppose say if I am batching 300 writes in a single IO operation, then I am more likely to consume 300 IOPS at the storage layer. So if your disks are 100% utilized, then subsequent write requests will be slowed down. So check whether if your disks are highly utilized. So make sure that the disks are not highly, I mean, ensure that you have sufficient bandwidth and in terms of IOPS or even the bandwidth as well at the disk level, guys. So finally, there are several blogs and books or even several metallic documents also that say set db fast object checkpoint parameter to false. Okay, this is not a good approach. This is not a good approach. So let me just show you in a different perspective, guys. So I'm going to start loading the data into my table. So one moment, I'm going to stop the load. I'm going to start loading the data into my table. So I'm creating the table and then start loading the data into my table now. So let it load. Let it increase in size. So I think this is more than enough, 700 MB. Yeah. So what I'm going to do now is, let me drop this table A, drop table B. I don't want this to come into the picture. So I have the table, students table, guys. So I'm going to create an index here, create index mark4 underscore IDX on students of mark4. Update. I'm going to run an update statement. Update. So I'm going to set this parameter to false and then show you the behavior. So update students set, update student set mark1 is equal to 1 to 3, where mark4 less than, suppose say 75. Let me show you the plan as well. Let me show you the plan once this is done. So at SS, what happened, guys? I don't even have this plan. Hello, everyone? Did it get flushed?
Is that still passing or?
The statement did execute using a index range scan only, but I don't have the entry in the shared pool also, so I don't even
Because
have
you
it
did not
anywhere.
commit. Because you did not commit, maybe.
Yeah, committing has nothing to do with the SQL ID in the shared pool here. So I'm gonna run a different thing here. So different child number, no, that is also not reason. Select counter star from $SQL. I didn't flush the shared pool or buffer cache also. So now what I'm going to do is I'm going to reduce this particular thing here. Reduce the IOPS. just to demonstrate you guys. So edit settings, IOPS. So I'm going to commit the transaction now, and I'm going to perform a full table scan here. Alter session set. So the data, so select AVG of Mark 3. Can you see I'm waiting on NQ first object checkpoint, everyone?
Yeah.
So it should take not longer. Okay, so I'm going to perform an stress on the DB writer to show you whether the writes are happening as well. So basically during an object level checkpoint, you would end up seeing the writes as well. So I'm going to stop this for now. So now I'm going to check this parameter. I'm going to set this parameter. So let's see now, guys. Let's see where this session ends up waiting on once the update is complete and then a direct path read is triggered. Let's see where the wait event, where this session actually ends up waiting on. So, and also look at the database writer stress output as well, whether if it in fact write the dirty blocks or not. So let's wait. So in the meanwhile, I'm going to increase the IOPS as well. So it's still running the update statement, guys. Let it run. So let's wait. The problem is replicating these scenarios are very cumbersome. So Rakesh, can you please place your call on mute? Yeah, that's all right. So let it, okay, even the 3000 IOPS is not enough. Okay, that's all right. Anyhow, I have the stress utility turned on. So I'm gonna remove this limits here. So I think it is complete. So now, did it write the dirty blocks here, guys? Everyone? Guys? So I'm gonna put it in a different way here. First, I'm gonna update this row again. Update this row. Commit this transaction. Post committing the transaction, I'm gonna limit the IOPS and then show you the behavior. Where does the session actually end up waiting on? So let it finish. So it's still running the update statement. Let it run. So it did finish up this. Now I'm gonna reduce the IOPS here. So I'm gonna trigger this particular thing. So let me just have additional things here so that. Am I writing, guys? Everyone, can you notice? Am I not writing the data? Dirty blocks? So can you see the weight event change, guys? Everyone? Hello?
Yeah.
Yes.
So it's not just NQTC contention you would end up coming up with. You would basically end up seeing under, I mean, due to the fact that I've limited the IOPS significantly here, I'm ending up with TC contention. Usually you would end up seeing this particular weight event base. So, and moreover, these weight events actually, I mean, under, since we are looking at intricate things, so Pat said, I mean, March PSU, I mean, things were different. And then today we are working on July PSU. So the latest July 2020 PSU. So here we are looking at MQTC contention. So you have to understand that you would even end up waiting on this particular weight event, even though the instance is a single instance environment. So setting this to false does not necessarily mean you are not writing the dirty blocks to the disk. Just because you end up waiting on a different weight event does not necessarily mean that NQKO fast up. Can you see the things here, guys? I'm not waiting on NQKO fast up checkpoint. Instead, I'm waiting on NQTC contention, isn't it? Everyone?
Yes.
So this is not accurate, guys. So you have to remember, you need to, I mean, these recommendations out there are wrong.
What is
So I put
TC
it better.
contention?
And we'll talk about those things later, man, when we
Okay,
are talking
okay,
about
okay.
weight events. You know, if we dig that way, we'll dig into move into some other part and then we'll never complete this thing. So database writers enough. You should also investigate along this line. This is valid, especially in environments wherein you have huge memory allocated and less number of CPUs. So I'll talk about these things in a later section. So you'll get to see the true picture when I'm talking about buffer cache. Now, finally, async IO is the predominant factor, guys, for an object level checkpoint. So more dirty blocks in the buffer cache, check this one as well. And there is another solution as well. You can also see, explore this particular path also, provided you have the license for partitioning. So the partitioning, you end up splitting the table. Suppose say 1 TB table into, suppose if you end up partitioning it into 20 partitions, each partition will become 50 GB. So the amount of dirty blocks written will become less, provided that you are not performing a select on the partition which contains almost active portion of your workload. Suppose say the orders table, if I want to check the orders for the past 30 days, I will be working on my latest data only. Latest data in this case, I will end up having more dirty blocks in the buffer cache, especially related to this partition only, not the partition which is 1 year older or which contains the data which is 1 year older. So you have to remember that. And moreover, this is a general recommendation. I mean, you can employ various buffer pools depending upon the object type and everything as well. So I'll talk about these things in the later sections, guys. But 99% of the time, you don't even have to move into this direction. So till now, we have completed how the full table scan actually happens in Oracle and what are things that actually come into the picture till date. So did you think that a full table scan had this much information, guys? Everyone?
No.
No.
Yeah, it is really overwhelming.
So
Vishnu.
wait until we move into indexes part. You will see too many things coming up. So I'll put it in a different sense. IO behavior completely changes under circumstances, under certain circumstances, guys. So I'll explain those things as well. It will be really overwhelming. I mean, once you get to know this stuff. But honestly speaking, go through the videos, guys. Go through the videos over and over again. Try reading it over and over again. So you get to understand things more precisely, and don't share these videos as well, guys. Starting from next batch, what I'm doing is I'm having the entire funds from this particular training course shifted to my old HM. Even this batch also, I'm shifting most of the funds there. So don't share these videos, guys. It does not worth it. I mean, honestly speaking, I have almost 35 old people who are dependent on us. So I want to make it self, what do you call, sustaining thing. So don't share these videos. And also one thing, guys, we are working on ATG for my old age home. Once that, it takes 3 months for that ATG to come into the picture. Once we get the ATG, so what I'm going to do is I'm going to send you the receipts saying that you donated directly to my old age home. Okay, everyone?
So ATG is a non-profit, right?
Yeah.
Oh,
Yeah,
Right.
basically we already applied it long back and that bugger actually demanded bribe and then we didn't do it. So now we are actually getting it done. So once that is done, I'm going to send you the receipts for that you have paid for that old age home, and then you can use that receipt to claim tax benefit as well, guys. This is not ATC, this is ATG. So if you fall under 30% bracket, you will get 5,000 back. So hopefully that should complete in the next few months.
Vishnu, you are doing a great work. We are with you. All the very best.
So that's the thing. And let me move ahead. So don't forget, by March, I think probably by Jan itself, I will get that ATG. Once that ATG comes up, I'll send you I'll do one thing. We'll see. I'll talk to the CA whether if, saying that you actually donated money using cash. You get it, right? Everyone?
Yes.
Yes.
So donated using the cash, and or I'll do one thing. So I'll ask you to send the money 15K to that account. And what I'm going to do is I'm going to send this money back again to your account using a different bank account. You get it, right? You send it to Jahnavi some account, right?
Yes.
Yes.
So I'm going to send the money back from this. You can send it to that account. I know that is not needed. I mean, that looks even way more fishy. So I'll actually say that, you have donated it using cash, and then, I'll send you the receipt. So you can claim 5,000 out of it. So if you fall under 30% bracket, otherwise, 20% or something like that out of that 15,000 you paid, you will get the appropriate amount back. So I'll try to do that. I'm not doing anything fishy here. I'm just taking, I'm just donating your money directly there, because just because we don't have ATG still, you cannot claim the benefit out of it. So moving on to Exadata, guys. Exadata cell offloading. If you have this parameter set to off, set to false, then smart scans will not happen. Smart scans will not happen. So direct path read does not also come into the picture, regardless of whether if it is Exadata or normal environment. If your table or a partition is way too small, then Oracle can consider DB file scattered read only. So if the serial direct read parameter is set to never, so there are even many few books, Exadata books, wherein they say you have to set it to serial direct read parameter to set it to never. So this is not good, guys. You need to take a prompt decision based on your load, and also configure the database in such a way that, so the first and the foremost thing you need to remember is, in an OLTP application, you have to prevent the full table scans altogether. So I'll talk about the normalization forms, normalization form, normalization 1, normalization 2, normalization 3, all those things as well, so that there you will get the clear picture as to why true OLTP applications does not even require full table scans. It is only the reporting queries which actually does that. So OLTP applications usually do not require you to make a full table scan. You end up only working on a subset of data which is very less only. So consider Amazon website or Remedy website. So you will end up looking at the tickets basically related to your team only, right? Everyone? You end up working on each ticket 99% of the time, isn't it?
Yes.
Hello? There are only a certain cases wherein you run reports, wherein you know what all tickets are resolved by me in the past 30 days or something like that. These things are not OLTP workload. This is not OLTP workload. So you will get to see things in more precisely. So then let's move on. So if you have a table space on Exadata environments wherein a data file is sitting on a file system and a data file is sitting on cell storage, in that case also cell offloading will not happen, smart scans will not happen. These are all the cases wherein your smart scans does not happen, guys. So if you have 245 more than 255 columns specified in your query, also in this case also the smart scan will not happen. If you are ordering the results by row ID way, in this case also it not happen, it does not happen. Flashback query requires you to basically read the data from the undo. So in this case also flashback, smart scans will not happen. Inherently IoTs are basically indexes. Smart scans are not possible on IoT. So index fast full scans, yes, smart scans can happen, but for an IoT they haven't implemented it yet. So clustered tables also you will not get. So I put it in a different sense. The clustered tables also the smart scans will not happen. If you have a compressed index, fast full index scan, and even a reverse key index also, smart scans will not happen. These are all the various scenarios. These are self-explanatory, guys. So these are self-explanatory. If you use any of these functions such as ORA, OAC and everything, and even if you create an index using no sort, then also, and if you are having a virtual column and then you are evaluating a predicate on the virtual column, cell offloading will not happen. If you have disabled the decryption at the cell level, cell decryption is disabled, then also the smart scans will not happen. So all these scenarios are, in all these scenarios, the smart scans will not happen. There are many scenarios, guys. These are close to 1, 2, 3, 4, 5, 6, 7, 8, 8 and then 16 scenarios, guys. There are even more as well. So how many, I'll stop the recording for now. So how many of you,
This conference will now be recorded.
so these are all the scenarios, guys, and moreover, I don't want to start up with this thing. So just I'm going to say a small fundamental, and then we can wind this session up. So when you are performing an index range scan. So what is the threshold, guys? Is it 1% of the rows from the table, or is it 2% of the rows from the table, or is it 3% of the rows from the table? Anyone?
So basing on the predicates it picks, right? So we cannot say upfront what percentage of the rules it will be.
So it is basically dependent on two factors predominantly. One is the clustering factor, and the second is the average row size. Even if you are retrieving 15% of the rows from the table, you end up with index range scan only. Index range scan only. How many of you think that it is not possible? Yes. So I have a students table here. I have the students table here, and I have the mark for column as well. I'm going to show you in a different way. Select count of staff from students. I do have approximately 10 million rows in it, I believe. So let me just bring it up here. So I did limit the IOPS, I believe. So one moment, guys, let me just change that. So once the lockdown is done, once the import restrictions are lifted, try building your home server, guys. So how many of you are in US here in this particular class, morning session?
Yeah, I am. No,
Yeah,
Vishnu.
I am
Yeah,
from
welcome.
Pankaj here.
So if you are from US, you can get a used server for damn cheap, guys. So ebay.com, you can get a Dell PowerEdge server. Dell PowerEdge server, PowerEdge 710 or 720. So Dell PowerEdge server, these servers are 720 servers. You can get these for damn cheap. But you have to remember, so see here, this is 27,000 only. In US, it is, if you are looking at a US website, you will get it for even very less price, 300 or 250, $300, something like that. So don't spend insane amount of money buying, expensive hardware. So it's just for practicing. So just try to get a PowerEdge server. You get, you can install ESXi, everything, guys. So Indian guys, Indian people, if they are in India, so once the lockdown restrictions are lifted, try AliExpress. AliExpress, you have X79 motherboards. These are Chinese motherboards, guys. So this is hardly $40, and you can get, you can you see my machine here, guys, everyone? Box.
Yes.
This is an 8-core CPU. Can you notice it?
Yes, yes.
So this 8-core CPU, you can buy it. This is a old one, guys. So I bought it long back. This one you can hardly get it for $50. So motherboard and processor will cost you $100, and DDR3 ECC reg memory, registered ECC memory. So if you want 64 gigs of RAM. So let me just bring it here. So if you want 64 gigs, hardly you end up spending 60. I think this is more than enough. So hardly another $100. With $200 or 14,000, near 14,000 rupees, you can get a decent 8-core processor, a motherboard, and 64 GB RAM. So you can do wonders with that. With this, you can basically get this configuration for just 20,000 rupees from AliExpress. Try buying those hardware and then start practicing.
You mean to say like the box is separate, board and storage. So all three are separate. We have to assemble it. You're saying.
Yeah, you need you once you get that, go to any computer shop. I mean, they'll assemble it
Yeah,
for you.
yeah, yeah. Yes.
Hardly, if you know how to assemble, then well and good. You can assemble it yourself.
Got you.
So why I am saying this is, don't see the laptop. If you have to purchase it to replicate, these things will cost you at least 80 or 90,000 here in India. You need to have at least Core i7 and all those things. Running virtual machines on a laptop will reduce the life of not only your battery but also the components. Also, the more overheating and everything, you eventually reduce the life of your laptop. So I'm saying this why, because I've burnt too many laptops, guys. I've burnt too many laptops. So just saying, it's not worth it. Just spend $200 and then get a decent workstation. You can install ESXi environments. You can limit the IOPS. You can even do whatever you want. SSDs are also way cheaper these days. So you can do wonders with those. So that's don't spend too much money. I mean, it's not necessary. So yeah, if you have 256 GB RAM, yeah, people will say yes, yeah, this guy has it. Nothing else. You cannot basically utilize 256 GB completely. So let me just go back. So I have the students table here. I have 11 million records. So let me just try to populate the Mark IV column in a different way. So instead of uniform distribution, I'm gonna use skewed distribution. I don't want to start the indexes part, half and then start tomorrow the rest. So that's the reason why. So I'm going to load data here about 10 million rows. I'm going to create a Mark IV index and then let me show you guys. So the clustering factor plays a predominant role in in deciding the threshold or the tipping point between the full table scan and the index range scan list. So create index. So let me create the index and then finally the statistics as well. So it should not take longer. So I have removed the restrictions related to the IOPS as well. So once you have this ESXi box case, you can simulate the hard disks also. You can just have a single SSD and you can basically limit the IOPS at each individual hard disk level as well. You can basically simulate multiple disks also. So that is way more good. So now select AVG of Mark 1 from students. So I want to gather the histograms as well. Students where Mark 4 is equal to 1 at display. So Mark 4 is equal to 1 has too many rows, guys. Too many rows. It would eventually come up with, Oracle should actually come up with a full table scan only. But here in our case, due to the fact we don't have a histogram here, Oracle will end up performing. So Oracle will end up with a index range scan. So let me just show you that. So I don't have a histogram here. That's the reason why Oracle is going up with this index range scan. So let me just execute a few others. So I'm going to show you in a different way now. Once the statistics are gathered for this particular table, I would end up having a histogram. Now I'm going to show you this. So the tipping point should be somewhere around 12 or 8 usually. So 12 or 8. So suppose say 7. Is 7 my tipping point? No. So someone has been meddling with my code here. Yeah. Someone has been meddling with my code here. So I think, yeah, okay, that's all right. So now 4 is the tipping point here, guys. 4 is the tipping point. Now let me just show you that as well. What I'm going to do is I'm going to create different table here and reduce the clustering factor, especially for this Mark 4 column. Create table temp as select star from students order by Mark 4. I'm going to create an index here as well, temp underscore Mark 4 underscore IDX on temp of Mark 4. Finally, gather stats on temp as well. So let me gather everything out. It's creating the index, yes. So let me see if there is a histogram or not. Select column name histogram from user underscore tab underscore call underscore statistics. Table name is equal to temp. I don't have a histogram yet. So what I'm going to do is I'm going to run few queries here. Select students where not students from temp where Mark 4 is equal to 123 c.123.123.4 c. So now I'm going to gather the stats again. Hey. So I've gathered the stats here. So I think I should have a histogram here now. Let me just show you that. So the data is same, guys. Nothing is different. The data is basically the same. It's only the clustering factor is different. So let me show you. Select count of star from students where mark 4 is equal to 4. So I have 2,63,000 rows here. I'm going to execute the same query here using mark 4 is equal to 4. Let's see what Oracle came up with. Can you see here, guys, everyone? Hello? So I'm going to I'm going to execute the same statement using students table, c dot temp dot students. So when I'm executing it using a students table wherein the clustering factor of mark 4 column is high, so I did end up with a full table scan. You need to understand that average row size and also the clustering factor plays a predominant role in determining the threshold or the tipping point between the index range scan and a full table scan as well. So even if I go with mark 4 is equal to 2, let me show you that. I'm going to replace it with temp here. So can you notice, guys, I did go with an index range scan only. Mark 4 is equal to 1. Here I did go with a full table scan. So let me just show you. Select count of star from temp. Select count of star from temp where mark 4 is equal to 2. When I used 2, Oracle did go with index range scan only. So now here, this translates to how many, guys? Even though I'm retrieving 8% of the rows from the table, I ended up with index range scan only. So your clustering factor plays a very important role. It's not 1%, 2%, 3%. So even if you have retrieving 0.1% of the rows from the table in certain circumstances, you would end up with a full table scan only. Even though you're retrieving 0.1% of the rows from the table, it's not, you should not consider, vendors and index scan come into the picture. So, the proper explanation is not the percentage, guys. Percentage in terms of number of rows, it's basically a factor of several things coming up. So I'll try to explain these fundamentals in the tomorrow's class. Starting from tomorrow, we'll look at, very interesting stuff. So, these first 4 sessions may look, a bit I do find people saying that it was way too complex, but no. I mean, I laid a groundwork for the next subsequent sessions as well. So all the subsequent sessions will become more interesting as we go along. So that's it for today's session, guys. Anything else?
Vishnu, you didn't explicitly gather the histograms, right?
Yeah, I did gather the histograms here.
Okay, the gather stats script gathers histograms as well, or it's all size auto, or what?
Normal command.
Oh, okay.
Because once I issue for certain queries, so Oracle, what it does, it tracks which columns are used in the predicates using sys.call usage table. Okay.
Yeah.
So I'll talk about more of those things later on, not now.
Sure.
So
yeah.
That's it, guys. That's it for today's session. Thanks, guys. Thanks for attending. Any doubts? So in the meanwhile.
So you will be discussing about the stats because stats has been changed in 19C and it is very different than
Yeah. I'll talk about those histograms. So at the last, guys, not now. So
okay.
Let's talk about basically full table scan, index scans, joins, optimizer transformations, everything. Then we'll proceed ahead with that.
Okay, sir.
So Vishnu, one question. This first start MTTR target, How does it
Mhm.
help moving dirty blocks from buffer cache to?
So if you have a dirty block beyond a certain threshold, Oracle, what it does is it writes it to the disk directly. It writes the dirty blocks. It does not let a dirty block stay for a very longer time
So
in your
let's say
buffer
my
cache.
value is something like 200. So it decides like
Mhm.
200 blocks can stay, or what is the
Mhm.
combination?
It's more like 200 seconds.
200 seconds. Okay.
Yeah,
So yeah,
it's
because
more
what
like
my
that.
previous knowledge was, I
Mhm.
think during the crash recovery only, it makes the crash recovery very fast.
Yeah,
Something like that.
crash recovery indirectly, this is what goes on. So if you are writing the dirty block, you don't have to apply the redo again, right?
Right, right.
You don't have to go through the entire history. You get the picture, right?
Oh, okay. Yeah, understood now.
So rolling forward will be way faster. So
Sure. And second question is this chain rows. So mostly I
mhm.
have seen, it's business driven. Let's say that when the business
Yeah, yeah,
started, in a table we were having 5 columns, and after 5 years
yeah,
we
yeah,
are
yeah,
having 25 columns. So I
yeah.
mean, we cannot have a liberty to choose the block sizes, table space sizes on the
No,
later, after few years and
no,
all.
no. DBS
So
do not. Basically, it's
right,
frankly
business driven.
speaking, I'll put it in a different sense. These days, why I actually explicitly added these things are, our role is evolving, right? Today. So it's not
Right,
just a
right.
DBA part alone. So in the next 4 years, you are going to work with NoSQL, everything. Your role actually transforms more into a database engineer or data engineer kind of a role. So this knowledge will help you insanely there.
Okay, got you.
So not even here now also you can use it, but you need to understand that the client also we should accept, right?
Right.
So that thing is also there. So anything else, guys?
Vishnu, just the doc, if you can just share that once again,
Which one?
the Exadata one.
Suraj Rajagopalan from which batch? So
Yeah,
A.
same. This batch only. I joined this
So,
second batch only.
sorry guys, I don't actually don't take it in a different way, but I do have a problem with my memory. It's not everyone of my, most close associates actually know that. While I was in engineering, I met with an accident, and then from that time, I don't remember things more for a longer time. So I just shared it again. So download it, Suraj.
Yeah, sure. Yeah. Just a moment.
Once you download it, I'll delete it. So I think the people have already done it out. Download it.
Vishnu, could you share the setup video once more? Because somehow it's not accessible.
Which video?
The setup video, the one
Setup
you,
video.
the VM setup video, which you initially shared.
So let me see here. VM setup video. Go to meeting.com.
Vishnu, could you please stop recording?